Welcome to this episode of Robert's Creative Chronicles. So today, we'll be solving this question, which states that perform 5 iterations of the bisection method to obtain the smallest positive root of the equation fx equals to x cubed minus 5x plus 1, which lies between 0 and 1. So solution. So this bisection method is based on the repeated applications of the intermediate value theory. So we are going to be applying the intermediate value theory to do the iterations. So now let's start. We have to do 5 iterations. And the interval, they have already given us the interval which lies between 0 and 1. So in this one, we're going to find the function of 0. So you take your calculator. This is the function, x cubed minus 5x plus 1. So we're going to find the function of 0. That is when we substitute 0 in this equation. So it will be 0 cubed minus 5 times 0 plus 1. The value of this is 1. So since it's 1, this one is positive. So hence, this one is greater than 0. So you write greater than 0 here, greater than 0 here, because it is a positive number, 1. So this is how we'll be doing in this bisection method. So now then the next one, and f1. So now this f0 is greater than 0 because it's 1. Then the next one, we'll substitute 1. So this is negative 3. So this one is less than 0. So we'll write less than 0. So you can see. So that means the root actually lies between 0 and 1. Maybe it's 0.5 or 0 point something. Because one number is negative, the other is positive. So since one is negative and one is positive, the actual root of this equation, when you substitute it in this equation, should give you 0. So since we have substituted 1 and gave us 1, the first one it gave us 1, then this one is negative 3. That means the root of this equation is between 0 and 1. So now we can conclude that this function times this function will be less than 0, because minus times plus will be minus, so it will be less than 0. So now we can say that hence the smallest positive root lies in the interval. Lies in the interval. The interval is what? 0 and 1. So this is the interval, hence the smallest positive root lies in this interval, 0 and 1. So now, from this interval, you can know that a0 is equal to 0 and b0 is equal to 1. This and this. So we will do the first iteration now. This is the first iteration. The first iteration, c1, is equal to a0 plus b0, that's a0 plus b0, over 2. So now this will be 0 plus 1 over 2, which is equal to what? 0.5. The first iteration is 0.5. So now we'll find the function of 0.5. So now we'll put 0.5 here. So this is negative. So this will be less than 0. Since a negative value. Then now, you can see that since this is a negative value, we have to find one from these two that is positive. Because since here is a negative value is less than 0, I have to find one that is positive so that when I multiply them to be less than 0. Because if it's not less than 0, we cannot find the root. So now, which one will we select between these two? It will be this one, greater than 0. We cannot select this one because negative times negative give us positive. So it will be greater than 0. So we have to select positive. So it will be and this one greater than 0. So therefore, f 0.5, f 0 will be less than 0, since negative times positive is negative, which is less than 0. So this formula is like we are bisecting these two intervals to get the middle. So now, hence the smallest positive root will lie in which interval? I don't need to write this again. So the smallest positive root now will lie in which interval? I'm just going to write the interval. So now the interval will be what? You know the above interval is 0 and 1. So now this interval, the only thing that changes here is this one because we are still using 0. So the interval now becomes 0, 0.5. So now in this one, this one will be a1 is now equals to 0 and b1 is now equals to 0.5. So now we'll do the second iteration. So now c2 will be equals to a1 plus b1 over 2. So this is how you'll be going, but henceforth I'll just be adding them and dividing them by 2. So this is the formula we are using. I'm just trying to show you the formula. So it will be this in two intervals to be 0 plus 0.5 over 2. So that's 0.5 divided by 2 is 0.25. So this now is 0.25. Then we are now going to find the function of this. Function of 0.25 is what? 0.25 cube in the original formula minus 5, 0.25 plus 1. This is negative. So since it's negative, it's less than 0. So now we'll find the one that is greater than 0 as we did before. So it will be and this is the only one that is greater than 0, so we're going to add this one. So when the two functions multiply by each other, it will be less than 0. So this condition, this is what we are going to use. So the product of these two conditions must always be less than 0 from the beginning of the solution to the end. So this will be what? f0 greater than 0. So less greater, this is positive, this is negative. Positive times positive. Positive times negative is negative. So it will be what? f0.25, f0 less than 0. So now, our interval now becomes what? In the last interval, 0, it was 0 and 0.5. So we are still using 0. So the one that changes now is 0.5. So it will be 0, 0.25. Because we are still using 0. So this 0 must still be here. So now, A2 is still 0. So A2 is now 0 and B2 is what? Is 0.25. So now we will do the third iteration. So C3 is equals to 0 plus 0.25 over 2. This is 0.125. 0.125. So now we'll find the function of 0.125. We'll find the function of 0.125. 0.125 cube minus 5 times 0.125 plus 1. So this is what is positive. So now that means this is greater than 0, and then we'll select the one that is less than 0 here. So it will be which one? This one. So it will be this and this. So f 0.25 is less than 0. So that means f 0.25 will be less than 0. So this will be less than 0 together, their product. So now the interval now becomes, in the last interval 0.25 is there, we are still using 0.25. So the only one that will change is this 0. So it will be 0.125 comma 0.25. So this is our new interval. So A3 is what? 0.125. B3 is what? 0.25. Then the fourth iteration. So the fourth iteration now is what? This plus this divided by 2. So it will be C4 is equals to 0.125 plus 0.25 divided by 2, which is plus 0.25 divided by 2 is 0.18. So 0.1875. 0.1875. So now we'll find the function of this. 0.1875. So now 0.1875 cube minus 5 0.1875 plus 1. This is positive, so this will be greater than 0 because it's a positive number. And then we are going to choose the one that is less than 0, which is this one. 0.25 less than 0. So that when they times together, it will be to give us a negative value that is less than 0. Less than 0. So now this is our interval now. In the interval here, 0.25, we are still using it. So it's this one that will change. So it will be 0.1875, then 0.25. So now A4 equals to 0.1875 and B3 is equals to 0.25. And B4, sorry, not B3, and B4. And B4 is equals to 0. And B4 is equals to, not B3, B4. Because now here is A4 and B4. Here is A3 and B3. So now we'll do the fifth and final iteration. Fifth iteration. C5 is equals to these two, 0.1875 plus 0.25 over 2. So this 0.1875 plus 0.25 divided by 2. So this is what? This is 0.21875. So this is 0.21875. Now we have done the 5 iterations specified by the question, and the smallest positive root lies is the midpoint. The smallest positive root is given by the midpoint of this interval, this one, which is 0.21875. So this is the final answer. The reason why we specify that one function should be less than 0 and the other should be greater than 0 is so that the root always will lie in the interval that we're going to use. Because if 2 of them are greater than 0 or 2 of them are less than 0, the root will not lie in that interval. So that is why normally if they tell you that the root lies between 2 intervals, if you substitute those intervals into the original function, one must be negative, the other must be positive. If one is not negative and the other positive, that means the root does not lie in that interval. Because any root, when you substitute it into its function, must produce 0 as the answer. So these boundaries, the boundary given to us, that is 0 and 1, the one must be greater than 0 and the other must be less than 0. Because if 2 of them are less than 0 now, that means the root does not lie in that interval. Or 2 of them are greater than 0. That means the root does not lie. But when one is greater than 0 and the other less than 0, that is, one is positive, one gives a positive answer and the other gives a negative answer, then the root lies in that interval. So that is why in all of these cases we have to maintain that, so that the product of the two functions must always be less than 0, meaning that the root lies in that interval. So as the question specified, 5 iterations, and this is our final answer. So therefore we can conclude that the smallest positive root is 0.21875 approximate. So therefore the smallest positive root of the given equation is 0.21875 approximately. I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email written in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.